There we go. All right, so I'm just going to use my highlighter to redraw these, and just so they're not overlapping, so they're separate from each other. That's kind of the goal when you separate and redraw overlapping triangles. So I'm just going to label as well. And somewhere in that diagram, they're going to have, because they overlap each other, either a side that's in both of those triangles or maybe an angle that's in both of those triangles. Can you guys tell, maybe if you look at the original picture before we separated it, what side or angle do the two triangles we separated have in common? Can you tell? What do you think? Yes, do you guys see that? So JK, right? This is across the bottom of this figure, JK here, JK here. So if we're doing an actual proof, which we'll do in a couple seconds, what I would be able to do is just use a reflexive property like we've been using a reflexive property. That segment is just in both of those triangles. It's across the bottom if you look at the two figures. Now, this one is a little bit different. So DEH would be here. And again, I'm gonna try my best to kind of draw it separated. It doesn't have to be perfect. I'm just trying to give myself kind of a little bit of an idea. Just draw the two separately. And so my yellow one was the DEH, and then my pink one is the DGF. Can you guys tell, maybe looking at the original picture before I separated them, what do those two triangles have in common? Yeah, this is really weird. We have never used this in a proof. This angle right here is in both of those triangles. Like on my separated drawing, it would be here and here. And actually, when we do that in a proof, it's just going to be like if we had a side in common, we're just going to use a reflexive property. We just haven't had any questions so far in our unit that would have had angle in common in the two triangles, because we haven't done any overlapping triangles. The only time that can happen is if the triangles overlap. Okay, so that's all we're doing there. So angle D is in both of those. All right, so these questions, and I promise they all tell you specifically what triangles that you want to look at, because there's multiple triangles I could draw from this diagram. So it's going to say to you separate and redraw, and then it'll tell you the triangles. So this one says ZXW, so that would be this guy here. So then I'm just going to come down, and I'm hoping there's enough room for you, but I'm just going to redraw it kind of underneath. And I tried to leave you guys a bunch of space too on the homework assignment as well. So I'm just going to separate them so they're no longer overlapping. Now, most of the time, this one has some markings in the diagram, but a lot of these diagrams will not have any of the given information marked. So when you separate them, if there's any given information, make sure you mark it up in your separated triangles. It'll make it a lot easier to see. When they're overlapped and you try to mark it up, it can be very confusing. So in the directions, and just because they are overlapping in the original picture, I had to be really specific about what angles I was talking about. But this says angle ZXW. So ZXW is going to be in my yellow triangle. The middle letter is going to be your vertex, and you guys can kind of maybe see this in the original drawing. But this has a triple mark on the ZXW. It's like right in here in the original picture. And then it says YWX. That would be the one on my paper that's in pink. It would be right here. And I'm just going to put, it has kind of a triple mark in the picture, but it's really confusing, I think, in the original. It also gives you two different angles, ZWX. Remember, this has a double mark. The middle letter is the vertex, so that's where your curve should go. And then this says YXW, so YXW, X is the vertex. That's where my curve is going to go. So once that's separated, it might be a little bit easier to see. Now, if you want to separate and redraw and number these angles or something, or call them like you could do that if you want, like angle W and angle X. That's fine with me as long as you separate them. I'm going to go ahead and just copy what they had though. Whoops, and copy correctly the given information. So ZXW was congruent to angle YWX. That was just literally given. I just remarked it in the picture. And then ZWX is congruent to YXW. Again, given, marked in the picture. Now, that's the only given information. So I have to use the picture to see if I have any overlapping sides or angles. So do you guys see any sides or angles that are in both of those triangles? What do you think? WX, good. Do you guys see across the bottom here? So I'm just going to say WX congruent to WX. And then there I got to use my reflexive property. We're using the diagram to get that information, but it's not given to us. So you want to call that reflexive. You could flip that over and say XW. That'd be the same thing. Okay, and then I'm just going to go ahead and use the congruent statement they say in the directions. So triangle ZXW congruent to triangle YWX. I would look at the separated ones to decide this, but what reason are we going to, just raise your hand and tell me, what reason are we going to use to say the two triangles are congruent? Yes, ma'am. You got an angle, a side, and an angle. So ASA. Perfect. Anybody having a question? All right. Let me try this one. Okay, I'm just going to grab two different colors. So ACB would be this triangle here. And again, I'm just going to try to kind of redraw it below. And then I have PRB. And again, just going to, I'm sure it's not going to be perfect. We're just going to try our best. And I'm only going to use the letters that I have in that triangle when I separate it. So ACB and then PRB. All right, and then this does not have anything marked in it at all. So they do give us some information. It says PB, which is in my purple triangle, and AB, which is in my kind of turquoise triangle. Those are congruent, just given to me right in the directions. So since that's a set of sides, anytime you got a set of sides or set of angles, that's part of your proof that you need. So I'm just going to say that's given to me. Then I've got, let's see, RB. So I'm going to put a double mark on that, and CB, double mark on that. RB and CB also just given to me. And then I have exhausted all my given information, so I got to rely on what do these overlapping triangles have in common. So do you guys see, maybe look at the original picture for this. What do those two triangles have in common? Bryn, what do you think? Angle B. Do you guys see that right here? This angle is in both of those triangles. And you can call it angle B because you don't have multiple lines running into it. It's literally just two lines run into that. Now, when you do it in the proof, you literally, just like a reflexive property, we're just going to have an angle instead of a segment here. So I just say angle B is congruent to angle B, so it's equal to itself. That angle is in both of those triangles, so that's a set of angles, even though we're describing the same angle. And that's just going to be your reflexive property. And then I'll go ahead, since they give me a congruent statement, I'll just go ahead and copy that. So triangle ACB, congruent to triangle PRB. Now, who can raise your hand and tell me which one of our reasons we would use for why these are congruent? Perfect. Side angle, side. You got a side angle in the middle, side angle in the middle, side. So SAS to abbreviate that. Is anybody having a question? Pretty much. This is the most difficult it will get. Pretty much. If you can separate and redraw these and mark them up, I think it will be not too bad to do. All right, so let me redraw GFD. There should be a little bit more space on these ones that I have on the back. And GHE. Because it can be confusing when you look at these diagrams. There's multiple different triangles that you could draw from this picture, so that's why it's important for us to be able to redraw the ones that they ask you to do. Oh, let me scooch this up a little bit here. So I colored the GFD on mine, kind of this turquoise color, and then I colored the GHE kind of with my purple highlighter there. And nothing is marked. So I'm going to look at the given information, which I just moved off of the screen here, so let me pull that back down. Okay, so D to F, which would be this segment here, and H to E, which is going to be this segment here, just given to me in the directions. And then again, I'm really describing the angles with the 3 letters because in the original diagram, I wouldn't know what angle I was talking about. But if you have separated them and you want to use less letters to do that, that's fine. But the middle letter should be the vertex. So if I say GFD, so it'd be GFD, so F should be where I see my curve for my angle mark. And GHE, so here's G, here's H, here's E. H is the vertex because it's the middle letter, so we're talking about that angle. And then I don't have anything else in the given information. I marked it all up. So maybe I should just go through real quick. Let me just copy those. So DF and HE, those were congruent, just a set of sides just given to us. And angle GFD and angle GHE, again, just given to us. So then I got to look for, if I'm trying to prove these triangles congruent, what do they have in common in the original picture? The overlapping, do they have an overlapping part with an angle or a side? Angle G, really good. So this angle, I'm going to put a double mark on it because I put a single mark on the other angle in the diagram there. So now, ultimately, this question, we are going to do a proof of why 2 sides are congruent. So I got to prove these triangles congruent first to do that. So I'm going to do angle G, just reflexive. That one's in both. And I got to make my own congruent statement here. So let me call, I'm going to call the one I colored blue, I'm going to call that GDF. If I call that triangle GDF, how would I have to label the other triangles so the corresponding parts would match up? Yes, good, good, good. GEH. Okay, now, why can you, and look at the separated picture, I think it'll make it easier to see. Why are these 2 triangles congruent here? What do we have in the diagram? Yes, ma'am. Okay, you've got an angle, and a side. Angle, angle, side. Now, if you guys remember from last couple lessons here, if my goal of my proof is to prove GH is congruent to GF, so that's going to be my last step. Now, I'm not going to mark this in terms of these segments being equal. I'm just going to kind of highlight them. So GH would be here in my separated triangle, and GF would be there. Those are corresponding parts. So if you guys remember this, if you show me the triangles are congruent, that forces any other sides or angles that are corresponding to be congruent to each other. Does anybody remember what we called that? Or we don't have an isosceles, not in this particular one. Yes. Okay. CPCTC. It stands for corresponding parts of congruent triangles have to be congruent. So those are corresponding parts. Those 2 segments we're talking about there.
So in the triangle, they won't give us what triangles we have to like.
It should. Now this last one, it'll at least tell you which ones to separate. But it should at least tell you to separate and redraw. It'll give you 2 triangles to do. This last one, you guys are going to have to forgive me because I think I put the diagram over the top of where it said that. So I'm going to have to give you the 2 triangles on this last one. So when I scooch this up here in a second, we're going to redraw triangle. You're good. SGF and HFG. Those are the 2 triangles. Like I said, I accidentally think I put the I think I put the diagram over the part where it says separate and redraw, so my fault. So those are the two triangles I want to separate there. Scooch this up a little bit. All right. And again, I'm just separating and redrawing to kind of help me see these a little bit better. So I colored my yellow one for SGF, and I colored the other one, which was HFG, in pink on this one. And again, they're going to be real specific about the angles, because in the original diagram, I'm not going to know what angle you're talking about if you just say like angle F or angle G, because there's multiple lines. When you redraw them though, SFG, that has to go SF is the vertex to G, so right there's where I'm going to put a single curve. That's congruent. HGF, single curve there. And then it gives me a set of segments. F to S and G to H. So let me just go ahead and copy those down into my proof. So angle SFG and angle HGF. Those are going to be just given to us. And then I've got a set of sides F to S and G to H, again, just given to us. I can't spell apparently, I'm giving. Okay, now, I don't have any other given information, so then I got to rely on the diagram to finish this proof up. What are the two triangles that, as they overlap, what do they have in common? Can you guys tell anything they have in common? FG. Do you guys see this goes across the bottom of both? I'm just going to put a double mark on it because I already used a single mark on another set of sides that they gave us. But our definition, or our defense here is just going to be the reflexive property because we've got that FG in both. That's pretty much how these go, for sure. You're not going to see like parallel lines in these or anything like that. It's just going to be to separate and redraw them. Okay, now I don't have a congruent statement. Let me go SFG, and I'll say that's congruent to triangle. If I go S to F to G, I went down the single mark to the angle to the double, so I got to do that here. So I'm going to go HGF. Why are these two triangles congruent? Side, angle, side. You got a side, angle in the middle, and a side. And once you've proven the triangle's congruent, the proof asks you to show that FH, which would be here, and GS, which would be here. So those are corresponding sides there because we know the triangles are congruent. That forces any sides or angles within those triangles to be congruent. So I'm going to say FH is congruent to GS, and we got to prove the triangle's congruent first, and then its corresponding parts of congruent triangles have to be congruent to each other. So that's CP, CP, C. If you got a 5-step proof, that's going to be the last step. If you have a 4-step proof, you are just proving the triangles are congruent. The 5-step proof is taking that one step farther. Is anybody having a question?